Hello there. So today we're going to look at the subject of testing. It's quite an important subject. So the idea is that we've got some software we've written. We want to make sure that it works, and not just in the terms of, just running a few things for our own benefit. We want to make sure that we can check everything, and that every time we make an update, every time we improve the code, the things that we had before are still working. So we'll talk about, in particular, a thing called unit testing, which is it's a professional practice, and we'll talk about how that fits into the code lifecycle. And we'll talk about what we test with the unit testing, because we can't actually test everything, unfortunately. It's not possible to test every single possible thing that the user can do with your code, so you have to try and account for what is possible to test. We'll look at a tool called PyTest, which is a plugin that you can use with PyCharm. And so we see how to configure PyCharm to do that. And we'll look at two important aspects of that. One is the assert statement, and the other is CAPSYS. CAPSYS is captured system output. We'll see what that means in a minute. And then we'll look at some examples. So we'll see the Uni app, the Uni broadcast app, some tests that we can put in. We'll combine those tests together. We'll look at how we test the pizza objects, Home Hub, and then we'll see how to run all the tests. So it's really about trying to make sure that whenever we change the code still works, including all the bits of the code that we haven't changed, to make sure that that they've stayed intact and they're still working. So motivation, we have done a little bit of this before. We've created test code. So for example, in topic 3. In Hub 02, there's a ceiling light test code that runs all the ceiling light methods for the programmer to check. Let's just have a look at that. So topic 3 was on classes. Hub 02, we had a ceiling light, which was a class here, which has some methods in it, and ceiling light test just runs those, just creates a ceiling light and runs it. It checks whether it's on, prints out, that will print out some information, then we'll switch it on, switch it off, and we check its status again. Okay, so that would allow us to visually check. If we ran this code, we can see whether the output is correct. But obviously, we know in this case what those methods are supposed to produce, because we built that software. We may already have forgotten, because that was a few weeks ago. What we really want, though, is some code that will automatically check this stuff. So rather than us have to run that code and check what the output is and make sure that it makes sense, which is quite error-prone and very time-consuming, what we'd like is to have some code that runs our examples and make sure that under a certain set of circumstances, not easy to say, under a certain set of circumstances, it will produce the right output. We can't test every possible set of circumstances, because it would just take too long to figure out what all the possible things are. Now, there's probably infinite ways that the user can use the code. So we'll try and capture what could be a reasonable set of usages by the user, and then we'll test that every time we run the code, they give us the expected output. Okay, let's finish that first video there, and then we'll get on to look at PyTest.